Hello, welcome to another video by Moxie Marine. In this video, I'm going to be continuing the build-up of a LS1 to replace a 5.0 in a Mercruiser boat. And I'm at the stage now where I'm ready to install the intake. This engine's been painted and it's dried for a week now, and it's now time to install the intake. This is not the final installation. This is a mock-up to see how things are going to fit and work out some logistical issues of how to make this all work. So I'm going to go ahead and install the intake manifold with the gaskets. Gaskets lay on top of the motor. I'm going to clip them. They clip on to the intake manifold before you put them on. Okay, the intake is now mounted to this engine. I spent approximately an hour cleaning this intake the other day, and I'm not happy with the results. Once I get it in light, I can see missed dirt spot right in there, missed some dirt in there, missed dirt back in there. You see it really well there, there. So also inside, it's still a little greasy. There's wet oil in there, so I didn't clean that good enough. And I cleaned it as good as I could. You just can't get inside there with your hands or anything. There's different ports and passes in there. So I think what I'm gonna do is I'm gonna take this intake back off. Like I said, this is just a mock-up. It's not the permanent install. I'm just trying to see how things are gonna go. I'm gonna take this intake back off, and I'm gonna send it to a shop that will do ultrasonic cleaning. And I think I've heard for about $40 they will clean your intake and 2 valve covers. I'm gonna send the, like I said, I'm gonna send the intake, and I've cleaned these valve covers on the outside, but you can't get to. There's a hole there and hole. Let's say there's a hole there, and there's just 2 other small holes there. Let me give you a bigger shot of it. But that plate is riveted to this valve cover, and you can't get the can't get inside there unless you take the rivets out. And then you do that, you have nothing to hold it back on there with. So that I'm not going to do that. So you have a choice of either buying brand new. I think these are brand new, $50 off Rock Auto. Or you can send it out and have it cleaned. So I'll compare the cost of cleaning versus the cost of new and see what happens. But both of them are that way. So that's two valve covers and an intake that I can get clean. Let's see what the price is, and I'll let you know how that turns out. But so anyway, back to the intake manifold. So at first I was going to, so right now I'm at the point where I'm about to install the fuel rails. I cleaned the fuel rails and set them down somewhere. Where did I put them? Oh, they're right there. So the fuel rails are cleaned up, and my first thoughts were I was going to put on a throttle body from a. So I can find out what I did with it. Let me pause the camera and find some parts. All right, this video is sort of out of order. You might get the sense that I'm jumping around a little bit, but I originally recorded about an 8-minute video talking about throttle bodies, and I've since had to come around and gone back full circle. So I'm gonna start over on the throttle body discussion and exclude that 8-minute video so you don't have to watch it. But the bottom line is that I've been going back and forth whether I need to use a cable drive throttle body or it's called drive-by-wire or drive-by-cable. Drive-by-cable means you got a cable, a mechanical, physical cable that touches the throttle and opens it up with a cable, a wire or whatever, and that's called drive-by-cable. Then you have drive-by-wire, which means it has an electric motor on the throttle body controlled by the computer, and that's what opens the throttle and closes the throttle. At first I was thinking drive-by-cable, and then I got to thinking, you know what, since I'm pushing Gen 4 engines that come with the drive-by-cable throttle body on this nice intake, it'd be nice to just go ahead and have my customers keep the drive-by-wire throttle body, and use that. And I did a discussion about 8 minutes long video that I felt pretty confident in that it would work. And then I went and did some research on the internet after the video and realized that the entire concept was not going to work. The reason is the drive-by-wire cable, drive-by-wire throttle bodies, the early ones before 2000, or the Gen 3, some of the Gen 3 engines had drive-by-wire throttle bodies, and they worked off what's called a TAC, a throttle actuator control. It was a separate computer that worked just the throttle body, and it had a gas pedal. The gas pedal is a sensor, which was feed to the TAC, and the TAC then operated your throttle body, so it was a separate computer for the throttle body. And then it would feed information back to the main computer, engine computer, on where the throttle was and stuff like that. Well, like I was saying, this is a 2000, this system came off of 2007, which is a Gen 4 intake and throttle body. And as it turns out, you can't control the 2007 up throttle bodies with the old TAC from the Gen 3. It doesn't work. The plugs are incompatible. Let me show you what I got here. So this is a throttle body from this is a 2007 throttle body. You see it's got 6 pins. And the throttle body from a 2002, the electronic throttle body, has an 8-pin connector. So the bottom lines are incompatible. And so I did some more research and turned to find out the 2007 up throttle body there is no TAC. It's controlled by the computer, which is the E38, which I've already discussed. That I don't want to use E38s in these builds. They're too complex. They're probably harder to find, more expensive. Software is more expensive. They don't have do-it-yourself support. It's just not. I just don't want to go there. So I'm trying to keep this as a nice, good, well-built engine with the least expensive electronics that'll run it as I can find from my customers, and so they can tune it themselves one day if they want to. It's also cheaper for me because the computers are less expensive, the wiring harness is less expensive. Overall, it's less expensive to go with the Gen 3 electronics and Gen 3 computer. So, having done all that, I have now decided to go with a cable-driven throttle body. Let me show you what that looks like. That's this. So you've got a cable attaches here, and the throttle body mounts there, and so basically you have a cable that attaches. 2 problems with that. One, there's no bracket on this intake to hold the throttle cable, so it can pull against something. I'm gonna have to design a bracket for that, which I will do. The second way is that there's no way to attach the MerCruiser throttle cable to this throttle body. You got this pin here was actually for the cruise control to pull on it. The actual throttle was down here with this the lead circle with a cable that wrapped around this pulley right here, and that was your throttle. So I'm going to rig up a special little piece of metal bracket that allows me to mount a MerCruiser pin for the MerCruiser throttle body. And what matters on these throttle bodies is the distance from the center of the shaft out to there. That radius is what matters because that determines the distance the cable travels for certain degrees of rotation. So your typical throttle body is going to rotate through about 80 to, so 90 degrees would be perfectly straight up to perfectly horizontal. So the number of degrees I'm guessing on this throttle body is probably about 80, maybe 75, 80. So you're typically going to rotate between 85 and 70 degrees of rotation, and so the radius of this from here to there in 80 degrees gives you a certain distance of travel. Well, if you look at a MerCruiser carburetor, which I happen to have over here, let's see if I can find it right here. This was 1.7 inches, 1.720 inches from the center of that shaft out to that pin right there. This is a MerCruiser carburetor. So 1.7 is well past this, which is about 1.265, I think. So it's going to be easy to make a bracket, for me to make a bracket that will bolt to this throttle body and also give you that 1.7. The other pin will be out here where my finger's at and give you that 1.7 distance. And I can't put it here because that would be, one, to be too hard to mount or too hard to attach the throttle cable, but also it's just too short. So anyway, I've got it figured out. I'm going to make that happen. That's not a problem. So I'm going to make 2 brackets. One to hold the throttle cable back here when it's pulling on the throttle. Another bracket on the throttle body itself for the cable attached to. Those are not very difficult at all for me. I have the ability to draw in 3D software. I can draw parts and get them laser cut, no problem. Then you've got the issue of mounting that throttle body to this intake. So this is what's known as a 4-bolt mounting boss. And this is the throttle body that came off. So you see I got 1, 2, 3, 4 bolt holes. That's the electronic throttle that came on it. And the throttle body that I'm replacing it with is this one, which is 1, 2, 3 bolt holes. So they're incompatible. Well, what do you do now? There's a solution to that, and I set it down somewhere. Here it is. So the solution is this adapter plate right here. It's ICD billet. Looks like the part number is 511XG. I'm not sure. But anyway, you see it's got 4 bolt holes that bolt there, and it's got three other bolt holes that the throttle body mounts to. So this is an adapter plate that mounts a 3-bolt throttle body to a 4-bolt intake. Actually, let's see. Here's the part numbers. The bag came out is part number 551511XG. ICT billet. I purchased this at Summit Racing. And I purchased that thinking I was going to do this originally, decided not to use it, and then now I'm back full circle back to using it. Okay, I've now got the adapter mounted. This is, like I say, this is just a mock-up. I haven't permanently mounted this. When I permanently mount it, I'm going to use orange Loctite on the threads of all four of these bolts here so it doesn't come loose. You don't need a gasket because it's already got a rubber gasket back here that seals the adapter up to the intake there. So that's the adapter mounted on the intake. I'm now going to go ahead and install the throttle body, and so you'll see what the final appearance looks like. Okay, I now got this Gen 3 throttle body, 3-bolt throttle body mounted on this Gen 4 intake. We're using the ICT billet adapter. I don't see any issue with this now, so I'm going to make a bracket that bolts here and allows a place for the Mercury throttle cable to come in and attach the other end attach here, and it'll open this throttle. No problem with that. Got to make a bracket to make the throttle attach here and make another bracket to hold the throttle in the back, and that part will be done. That's going to be fairly easy to me. The downside of this design or this concept is now you've got a Gen 4 engine and a Gen 3 throttle body. So now you've got to source a Gen 3 throttle body from a different source than your Gen 4 parts. I believe you can find these on eBay all over the place. I will double check this and I will put it in the description, but I believe this same throttle body can be found on a 96 through 99 Chevrolet truck with the central port injection. I'll have to check on that, but I believe I'm right. And so there's plenty of sources for these Gen 3 throttle bodies. All right, I believe this throttle body discussion is now complete, and I will return the video back to, I believe I'm going to put discussing about the fuel rails next. Okay, now I have the fuel rails placed on here. I haven't really bolted them down. I've just got them positioned back on here. These are called EV6 connectors. A lot of times they're not compatible with the older Gen 3 harnesses, which you will need a Gen 3 harness if you want the proper plugs for a Gen 3 computer. So to solve that problem, I bought this kit right here. This is a EV6 US car fuel injector connector kit. This converts your older style. You have to cut the wires and basically crimp these connectors on there, but this gives you 8 EV6 connectors for these type injectors. So I'll have to modify the harness for that. But these injectors are superior to the older injectors. Plus they are a certain height. These are called truck injectors. They have a shorter distance from here to here. And so you have to use these injectors for this type fuel rail. And plus, since you get the injectors with the intake and the engine, you might as well use them. So it's easier to just modify the harness with those plugs. All right, so I've got the fuel rails installed. So let's discuss this. This is a fuel filter. It's from a 2002, 2003 Corvette. The AC Delco, I believe, is GF822, and they're about $90. The Wix version of this is $33,737, and on Rock Auto, it's about $42. The AutoZone version, which this is of the Wix, is $23. So I got this for $23. If it doesn't work, I'll be returning it to AutoZone and get the Wix. But for now, you can't beat that price. So this obviously looks like a fuel filter, but this is more than the fuel filter. If you notice something odd about it, it's got 1, 2, 3 pipes. Now, why do you need 3 pipes for the fuel filter that has an in and an out? The fuel comes in, it's filtered, it goes out clean. Why do you need a 3rd port? Well, the purpose of this is this is not just a fuel filter, it's a fuel pressure regulator. And it's permanently set to maintain 58 PSI on this fuel rail. It's from a 2002, 2003 Corvette, and it's mounted low on the frame, but you can snap it. If you notice, I've got it snapped onto this fuel inlet on this fuel rail, and this is what's going to supply fuel to the engine. So your inlet, your fuel coming in from your pump would go here. The fuel going out back to your tank would be here, and then this is the fuel supply to your engine, to your rail. I'm not super keen on this, even though I think it's functional, it works. It's just not aesthetically, it's not really doing it for me. I'm gonna look into I may do something different, but right now, if I do this at all, I'm gonna make a bracket that mounts on this tab here, It's probably gonna come off the valve cover, and then you mount this to a bracket that holds it steady so it can't move around. See how it's kind of moving around a little bit? I want that rock steady. I don't want that moving at all. So I'll make a bracket that mounts on the valve cover if I choose to keep it in this location. Obviously it's cheaper in that location. Let's say if I were to move it down right here, use this bolt here for that, and it looks like it would swing around and it would bolt right here just fine. It would sit right here on the back of the motor. Now you've got to come up with a fuel line from here to the fuel filter. It needs to be a braided steel line, which adds expense, quite a bit of expense. So I'm trying to avoid that. So I'm going to keep messing with this, or keep playing with this fuel regulator and see what I can do. Let's see what else was there. If you notice, I took the tape off the valve rockers. I'm about to install the valve covers because I was going to see what I was going to do with this bracket. All right, turning to the video, I've now installed the valve covers on both sides, and I've temporarily placed the ignition coil pack on the port side valve cover, and it doesn't take much, doesn't take a rocket scientist long at all to figure out that the exhaust, the LS exhaust, LS marine exhaust, which is going to come right up through here, is going to hit these ignition coil tips. There's not even yet, I don't even have the spark plug wire on here yet. And so you can clearly see that these are going to hit, this piece right here is going to hit the marine exhaust. So to solve that problem, I'm going to make brackets that move this up and vertical about right here, somewhere about right here, so that it clears the marine exhaust. And at the same time that I make that, let me set this down here. When I make that bracket, I will also make it such that I'll put a hole in it for this so it'll kill two birds with one stone. I can also bolt this to that bracket and hold it rock steady, and that'll be a nice little setup. And the nice thing about, so the coil packs are symmetrical. Both valve covers are symmetrical. The pattern to attach things is, well, I say it is, and maybe it's not. Huh, that's weird, interesting. So, it looks like this one, that one, and that one over here, there, and there. This one is there because that corresponds to this. This is not there. It's not on that side over there. This is not there. And then over on the further out, I've got this one is here. There's not one here. There's not one here like the shows here. And then I've got that one up here real high, which is this one, but this one is not here. So, or this one is not on the other side. So that's interesting. So I assume they were symmetrical. They're not. I'm going to test fit this coil bracket on both sides to see if I need two different brackets, but I hope I don't. You get a much more economy of scale when you can make one bracket to do multiple things. So that'll be for every engine. I got two brackets, and that means I can get a better price for everybody when I buy them. So anyway, I'm gonna make a bracket to all the ignition coils, and let me go find the ECM, and I'll continue discussion on that. Okay, I tried this same ignition coil pack. It's 4 coils in one setup. I tried it over here on the starboard side, and it fits okay. It is symmetrical, at least for the coil pack. So I can use one bracket for both sides. All right. So that seems to have solved the problem with the the coil packs. Now I'm gonna look at the ECM. Okay, so this is the computer that's gonna be running the system. It's known as a 411 PCM. Came in, let's see, there's 411, and it came in about 2000, 2004 Chevrolet trucks, cars, LS1, Camaros, Corvettes, everything. So it also came in 4.3 V6 engines, still running the old central port fuel injection and the old ignition system. So it's really a very widely known ECM, and all you have to do is reprogram it to repurpose it for whatever needs you want. So the point I'm making is that I have to put this somewhere, and it can't go here, can't go right here, because I'm putting the fuel rail, I'm using a Volvo Penta fuel module here, and it's going to go right there in that corner, and there's really no other place I can put that. I'm going to put it up. I'll be making a bracket that comes off the cylinder head and comes up a little high and mounts it up here, right in this area. So, because the I may try to find a different water pump that brings this out this way instead of back that way. That's going to be, I know on my truck I've got one that brings it up coming out this way, so I may find one of those, but I'm not sure yet. I'll route the hoses later. So the ECM can't go there, and I don't want to put it down low. I'm trying to keep everything electronic or electric up high so that if you ever get one of your builds, none of your electronics will be submerged. You can have, these sensors here are waterproof, so it's okay if they get submerged. That one, and the crank sensor over there by the starter. But ECM, it looks to me like about the only place I've got left to put it, and I'm starting to understand why Mercruiser did the same, is I may have to put it on a bracket mounted right here on the side of the port exhaust. It's gonna be kind of a tight fit with the ignition coils. And I also worried about electromagnetic interference from the ignition coils on this computer, so that may be an issue, but we'll see. So anyway, I think a bracket that's mounted right here, I'm trying to get a better picture for you, a bracket mounted right here with the on the side of the port exhaust is where I'm gonna have to put this computer. So not quite far enough along to do that yet. My goal is to get this engine running, and then I'll buy the marine exhaust once I've shown that it runs. So we're close to that. Like I say, pretty sure that's where I'm gonna have to put these in, because the cooling system is gonna have to go down here. I can't put another side, the starter's down there. So it really leaves over here on this side for the cooling the cooling heat exchanger. This is going to be a closed loop cooling system with a heat exchanger, and really right under here, underneath the engine mount, is about the only place I can put it. My worry is that a lot of times your runners on your boat run right through here, and it would hit the engine might sit down between the runners, but the cooling heat exchanger wouldn't. So I got to be real careful about that. So I'll have to figure that out. But anyway. That wraps up this video anyway, about install accessories. Obviously I can't put anything here because the alternator and the power steering pump all go right here. That space is taken up. So I'm gonna go ahead and close this video out, and then I will do another video on once I get the heat exchanger figured out and the ECM figured out. Thanks for watching, and subscribe if you find my videos helpful.